am Paolo Cherubini. I'm a postdoctoral research associate at Heriot-Watt University, Orkney, originally from Italy, and I'm working as part of the transition engineering team in a UKRI fund project called Dispatch, which looks at decarbonization of heating and cooling in residential households across UK. But we are particularly focusing on Orkney as a case study, applying the transition engineering methodology to it. So I wanted to talk to you about what we are doing for approaching a net zero electricity system with no fuel poverty. So to give you some context about Orkney, Orkney is an archipelago situated in the north of Scotland, which is well endowed with renewable energy sources, especially wind, wave, tidal, and especially for wind, Orkney has experienced a massive development of wind turbines, starting from the first tests done in the 50s. And nowadays, since the grid couldn't accommodate enough renewable generation capacity, the first smart grid in the UK was done here in 2009. It's called the Active Network Management System. And the result of all this development, you can see it on the right in light blue. You can see all the spots where wind turbines are located in Orkney. So these would range from massive wind farms to residential wind turbines from 5 to 10 kilowatts. And in light yellow also we have photovoltaic systems. So there is a lot of renewable capacity here, but Orkney is also interconnected via subsea cables to the Scottish mainland. But from the graph on the left, you can see that local generation is erratic, is intermittent, coming mostly from wind, whereas demand is more or less steady and revolving around a steady average value. So what we can observe in this current system is that 120% of yearly electricity needs are supplied by local renewables. If you take volumes of electricity in kilowatt hours, let's say, but at the same time we have, from the latest estimates, fuel poverty rates that are ranging from 49 to 73%. So clearly there is a mismatch in, as you can see from the generation pattern, between renewable energy availability and demand of electricity. And also there is a structural mismatch between all this richness in electricity supply and the availability of people to use it affordably to achieve a minimum level of comfort and well-being. So we approach at first this issue by applying the transition engineering tools. So the wicked problem exercise, we did it internally, we did it with local stakeholders and with fellow researchers, and what we distilled from considering the 6 perspectives of the essential activity of supplying this minimum level of electricity that is needed for well-being at home, is that fuel poverty is allowed to happen within the existing system of regulation and market. So there is no way structurally to prevent fuel poverty from happening. It's just an externality, and the solution would be that we cheaper renewables with more technology. At one point the problem will end, will just end on its own, and this benefits of green technologies would spill over to everybody. But Orkney is such an interesting case study also because it shows that this general trajectory doesn't lead to the desired result. So when we also did the in-time method, by applying the in-time method, we saw, especially when taking the step into the future in 2021, what we saw that electricity in Orkney will still be supplied by renewables, but fuel poverty will not be possible by design. So the system will be restructured in a way where fuel poverty isn't possible. But that means that the system will work under different criteria. So all the generation storage, equipment, technology will in place in this renewable, let's say net zero system, will not try to mimic the same way of the same regime that the power system had so far in the last century, where we had access to affordable, cheap, and careless use of fossil fuels. So this is the shift that needs to happen. In this illustration, which is a bit cramped, we just wanted to show what are the multidimensional view that we are taking of this problem, and what are all the domains that we need to consider at the same time. So there is the generation, how electricity is produced, and what are the generation patterns of electricity, how they are treated in the market, which currently again is not really linked to final consumption, but it's just a unique UK-wide system. The regulations that enables the market to happen, and so we would like to focus here on designing a shift. And on the technology side, we have all the controls that allow the grid to operate in a stable way, and also to automate some of the behaviors and loads so controls to enable flexibility on the end-use technologies, and then we have the physical network, the neighborhood network, we could call it here. It's a rural distribution system, and also we want to consider the well-being aspect of it. So electricity consumption has to be safe, has to be reliable, and has to be available in a sufficient amount to ensure well-being, and not a state of deprivation for citizens, for users of electricity. So here we took another pillar of transition engineering, which is the anthropogenic system dynamics, but we put in the center the same model of the electricity network and the power system as a whole. And our current work would be to build a forward asset planning model. So this is why we are working to retrieve the data that we need to first have a model that is able to reproduce the current behavior of the electricity grid in Orkney, and then have a way to tweak the rules and the structure of the system as a whole, and see in the model first how it will change to get to a pathway that is compatible to our view for 2121. So the concepts that we would like to plug into this forward asset planning model that we're building, for instance, are the social gifting market. So based on the experience that traditional societies and community economies of sharing excesses, we would like to bring this idea to electricity, so have a way to share excesses of renewable energy to be shared for free for use in the community to ensure well-being for everybody. And so we would like to see how the market arrangements for such a gifting market would work. And the other one is the perspective of essential energy services, or energy sufficiency rather than efficiency. These are some ideas that are well rooted in the literature and in the energy demand studying community. We would like to see how we could split the electricity market between an essential, a minimal level of provision that is treated as a public service and is made available affordably for everybody, and everything that comes after that is a surplus, and it's treated differently, maybe in a more regular market arrangement. So this is what we had in mind for the for our electricity transition lab. And also, as a final outcome, we would like to see what the design criteria for this new system would be in general. So thanks for your attention, and enjoy the rest of the conference, and feel free to approach me if you're interested in this topic. Bye.